without doing that. It does not take me any extra time, nothing, because I am taking, because all item you are not taking from one location. You are pushing the trolley, take differential, right? I am just adding. Approximate. That's all. So even with that my math skill, I do not will go to that. What I'll do? I'll be using this one. This is my normal, this is my tangential, this is my absolute. And I'll be measuring that length, multiply with my scale, and I'm happy. Within a few seconds, I got the answer. Alright, so we did that one, and then another thing. Look at here. This is our normal ABAN, and this is our ABA tangential. So from here, if I draw a dotted line up to that point, that is our absolute relative ABA. Clear to everyone? And this one is our AB normal, and this one is our AB tangential. So if I draw from the origin of the AB normal a line, draw a line up to that point, that is our absolute AB. Clear to everyone? Otherwise, young people, we have to use these things, and which you don't want. Why? Because it will take time. You can do it when you are at home. No problem. Then okay, I test my mathematical skill and so on. But when you are in the exam or in a very tight time, you always find a shortcut, but accurate. The ordinary way. Okay, so we finish everything. So what do you need to do? Look at here. We measure this length, multiply with this scale, we get absolute ABA. That is our this value. And then we measure from here up to that point, that is our absolute AB, that value. And then we measure from here to here, that is our AA. Look at here, how quickly I did. But this is the arithmetic sum, you don't put the value and then sum them up because they vector sum. Okay? It will not be the same way. Clear? Now, and then this is our tangential part from here up to that point. If that one equals alpha BC times RBC, and from there we find our alpha BC, the angular acceleration of this link. Clear to everyone? And our ABAT, this one equals alpha AB times RAB, that value of this one, and then we get from there alpha AB. And subsequently now, as you have it, absolute relative acceleration is this line, you go to the midpoint here and you connect from the origin up to that point, you find your AE. Again, I draw your attention. Look at here how I quickly showed. You need to find your AE, absolute acceleration at point E. So what do you do? And that is the midpoint of your AB. And the AB relative acceleration is that line from here up to that point, which is the normal and tangential combined to give you ABA here. So you go, that is the midpoint, you come up to midpoint here. And that midpoint, you connect from the origin up to that point, that will be your AE. Is it clear? And your AB, now AF, it will be half of that. Not exactly half of that, because you need to be a square divided by R. Clear? So it will be half, because you are dividing by half. So it will be, the square will be a little bit less. And then from here, tangential component will be also half, or whatever it is. And then it will, you draw these things there. And then your F, it will be bigger, so it will be bigger scale. This one and this one will go there, so and you combine maybe somewhere here, it will be your AF. Or you have to do the math equation exactly I did here. And this is how you'll be finding. Clear? Again, young people, I did not do any different thing. I exactly said the same thing which I started with. Now look at here again. This one is BB square divided by RBC, correct? So when you go for that midpoint, it will be BF square divided by half of that. Clear now? So it will be essentially half. And then your tangential component will be alpha BC. Remember that? So because your tangential component will be from there, like that. It will be still perpendicular. It will go like that. You can draw it here. And then you connect this normal and tangential, that will give you your, that one, BF. AF. Or you have to do mathematical calculation here. Alpha, you need to find normal component and tangential component, and then you do it. But if I'm in your position, if I don't have a time, I'll be doing it graphically. So what you do, my humble request to all of you, you do first here, using that. And then you do here, and then take the value from there. And if you see the same value, you found the calculation. Okay? All right, we move on. But in the exam, I will not be making that because that's so complicated, because otherwise some of you will be studying. Okay? I'll be giving maybe 1 or 2 points, 1 point or something, if I give. Now, this particular principle, every one of you know when you did your major assignment. There is a Grashof principle we call. And you know what is the Grashof principle? Anyone can tell me why it is important? Yes. In a formal linkage mechanism, if you at least one link should have a 360-degree rotation, you need to have, so look at here, this is OA, AB, BC, and OC. OC is the ground. So, in order to have at least one link, either BC or OA, to have a 360-degree rotation, you need to cross-check with your Grashof principle. It is not 100% correct, but it is almost 95% correct. Okay, so if anyone say Grashof equation is 100% correct, no, you don't say it, but most of the time it is correct. So what happens? It says, in order to have in a 4-bar linkage mechanism, at least one link which has a connection to rotate 360 degree, it says that the length of the smallest link plus the largest link is less than equals to other 2 links. And that's the things it is shown here. In our case, the smallest link S is our AB. And largest link is our BC. Oh, sorry, OC. I think it's longest is the OC, most probably it looks like almost same, but that's OC. So in simple thing, you will be always taking the largest one and you measure it. Which one is the small, which one is the largest. You don't need to guess. You can see it. So you add them up, and that will be on the left hand side. If that one less than or equals to other 2 links, then it means your one link which is the connection, it will have 360 degree rotation. Clear to everyone? But in your assignment, you actually did that testing. Many of you forgot about it. Remember, some parameter we gave you, some parameter you determined, and you used 2 non-equality equations, and one of them actually the Grashof equation. Clear? Remember, you used a non-equality equation, you put some values you guessed, and then you see that left hand side is less than the right hand side or not. First equation is actually Grashof equation. Alright? So that's why I wrote it. So in case you forgot this one. But you have done already. Alright, this particular problem, this is another example. I will not spend a lot of time. This one is the same process, but I tell you how I did. Here, look at here. Hey young people. This particular example 3, if we ignore the C, it is a crank, connecting rod, piston mechanism, our first example. Isn't it? If we ignore our point C, that section, our AC or BC, if we ignore, then it is essentially is a crank, OA, AB is a connecting rod, and piston is a B. It is just opposite way we did it the other one. So in this question I asked you to find the velocity and acceleration not only at point B but also point C. So how you will be doing it? At the moment, first your step will be not to find C. C does not exist to you. To you, it is a crank, connecting rod, piston mechanism. That's our first example. So what do? You will find the velocity at point B equals velocity at point A plus B, velocity B related to A. And you find the velocity BB. Is it clear to everyone? That's exactly what we did here. Look at here. The the velocity VA, because VA is a perpendicular to it, that's why our origin is here. It is going this way, because omega is rotating anti-clockwise. So our VA is from here going up to that point, and then our VBA is a perpendicular to it, that is our VBA. From the tip of VA, it will be going either that way or downward. So we draw that dotted line perpendicular to AB. And then our VB should start from the origin of the vector polygon. It is the horizontal direction. So that's why we put this dotted line, which is our VB parallel to XX. Clear to everyone? So where our this line and this line intersect, so from there up to that point will be our VBA, and from here up to that point will be our VB. Clear? As we did our first example. And now we'll be looking at our magic. Our magic is now we can go to C. How we can go to C? Look at here. We can write two equations, which I'll be doing in the next example. And you also have done in your assignment for point C. Your B, you don't have a problem. You did immediately. But your C is a general plane motion, that's why you are in big trouble. That velocity at point C, absolute velocity and absolute acceleration, AC and BC, they are neither perpendicular nor to parallel any of the link, because parallel, the general plane motion, it's the combination of the two different type of motion. As a result, velocity, absolute velocity, is neither perpendicular nor parallel to any of the motion, any of the links, sorry, not motion, any of the links. So that's why you don't know the direction. If we don't know the direction, we cannot plot the vector polygons, as I said to you. That's why we did some trick, which I'll be showing you here. So as we know now velocity at point B and velocity at point A, our life is absolutely easy. So what we did, we set up two equations. Or we can actually do it here. Either way. But I show you the next step we'll be doing, like you see. So I set up BC equals VA plus B related BC, C related to A. That's the one equation. And the other equation will be the velocity at point C equals velocity at point B, which we already know now, because our velocity VB is here, that parameter, plus C related to B. So BC equals VA plus BCA from known to unknown, that line. And another equation we write from known to unknown, because we know velocity at point B to the velocity C, which equals VB. I'm writing it here, then it will be easier for you to see. We don't need this one anymore. And you can do it at home. Now look at here. I write two equations. BC equals from known A, VA plus BC relative to A, equation 1, and BC equals VB plus BC relative to B, and that is our equation 2. Problem is here, our velocity at point C, it is a general plane motion. As a result, the direction of BC we don't know. The absolute velocity at point C is neither perpendicular to AB, neither perpendicular to BC, nothing or parallel to BC or parallel to AB. So it means this BC is neither perpendicular or parallel to any of the links. So look at here. Here we know the direction, it is perpendicular to OA, and this one we know direction perpendicular to AC, because relative velocity perpendicular to the respective link, we know, but we don't know the direction of this one. And then if we come here, this direction BB, we know it is a perpendicular to, not perpendicular, sorry, parallel, this one parallel to X and X, and this one is the perpendicular to BC, because respective link. But this one direction I don't know, so therefore I did not think the all direction must be known. I cannot compromise. So what do we do? Then we say, okay, as we don't know your direction, look at here, BC equals BA plus BCA. BC equals known from known point BB plus BCB. So I equalize these two. Temporarily, this BC, which is making a problem for us, we eliminate it. So how I do it? Look at here. Here I write that BA plus BCA equals BB plus BCB. And here I know it is perpendicular to OA. I know its value. And this one perpendicular to AC or CA. We don't know its value. This one we know it is parallel to X and X. And we also know its value now from our vector polygon. And this one is a perpendicular to BC. And we'll be plotting our vector polygon. To find these two unknown. This unknown and this unknown. So how I did? Have a look. Acceleration I will not be doing. You will be doing at home. Process is same. Look at here. Look at here. Because the equation I did not put it here. I think maybe next page I put it. I'll see whether the next page I put it or not. Just 1 second. Yes, I put it here. Okay. I put the equation. You see? I initially thought that I didn't put the equation. So, what I did, have a look. Have a look. Our BCA, our this one, BA, our BA is this one. So, our BCA is a perpendicular to AC. It will start from the tip of where our BA finished here. And therefore, perpendicular to this beautiful red dotted line is our BCA perpendicular to AC. Clear to everyone? I'm not interested about ABA anymore because it has nothing to do with that line. ABA, it is for connecting dot AB. Our velocity VBA, that one, it nothing to do with our SCA because it is a different side and different side. So now I draw the dotted line here, and then I move on to the right hand side. Right hand side our BB. What is our BB? BB is up to that point. So it means our BCB will start from the tip of that one. How it is directed? Perpendicular to BC like that. Clear to everyone? And that's the beautiful line. I draw a dotted line passing through where our BB finished. So from here it can go to the left or from here it can go to the right. So I put a dotted line, very continuous big one. And then this is our BCB perpendicular to BC, and this is our BCA perpendicular to AC. And these two dotted line, one is our red dotted line, another one is a light blue, I think is which line? Green line? Yeah, green line. This green line, and where that intersect, from here up to that point is our real BCA, and from here up to that point, that is our real BCB, and therefore, where these two beautiful, the radial velocity intersects, that point if you connect with your origin is your BC. And if you don't believe me, check your equation. BC equals BA plus BCA. BC equals, that first equation, BA plus BCA equal BC. Again, look at here, BC equals BA plus BCA. BCA is from here up to that point. Therefore, this, if you draw the diagonal, that will be your resultant vector of these two. And then BC, our BC equals BB plus BCB, the other side. So our BB is this equation, and this is not equation, this line, and from here up to that point is our BCB. So the diagonal of the two vectors will be our BC. Hey, young people, we found everything here. Clear? The same process you did in your assignment. Is it clear or not? Yes? Good. All right. Because this is your BB, this is your BCB. So therefore, BB and BCB diagonal diagonal will be the resultant vector, which is your VC equal VB plus VCB. And your VA and your VCA, diagonal of that two vector will be your VC again as per our equation 1. Vector. And when you learn in vector in high school, hey, young man, you see, you remember everything. I believe that those who did the science stream, you did it somewhere in class 9 or something. You are right, very similar. Yeah. So when you finished your class 9, which year, young man?
2000.
Do you remember? You forgot?
2014.
2014. And I finished class 9 in 1979. Okay. Actually 78, not 79. Yeah, no, 79. Long time ago. All right. Hey, young people. I will not do the acceleration. You will follow the same process, exactly the same approach. Only you split in normal and tangential. Clear to everyone? And I did everything for you step by step. I didn't skip anything. So you will go to that one at home. And you look at here how I did. The dotted line, it means unknown line, and then it intersected. We found the real value. And now, look at here how I did. You see how, look at here. From vector polygon we get, you see how I wrote? Now we get angular acceleration. How I wrote? It's systematic. Engineer always need to be very systematic. All right, our last example for today is this one. Now, how much time we have, young people? Huh?
Less than 1 hour.
50
Okay,
minutes.
fine.
50 minutes.
Yeah, that's fine. 50 minutes,
Yeah.
50. Okay, that's fine. Because I will finish this one quickly, and then we'll start our instantaneous center introduction, and then tomorrow our first half we will finish our instantaneous center part, and then we'll move on to our the balancing part. And after balancing, I'll take another 10 minutes to give you a little bit of hints and how you will be preparing for your exam. What are the topics you need to look at, and how we will be tackling various problems. I'll give you a little bit of advice, and if you think, no, I'm already expert in this subject, I don't need any of your hints, thank you, you can go.
Eric.
All right, and if you say, no, I also want to hear, that's fine, you sit down another 5 minutes, and then you go. So, decision is yours, young people, we are living in democracy. Fight for democracy. Everywhere in the world. And one country with the flag. Still. If you don't listen, of course. But we are not talking about that. We are not in politics. We are purely in our engineering dynamics. I'm not talking about Singapore. Singapore is not that category. This is good category. Singapore, at least one thing. Any country need to make sure the very basic fundamental things human need, the food, the shelter, the health, the education, and then there are also which of the health, education, food, shelter. The 4 fundamental things you need to make sure. After that is coming whether you can talk all the right thing or wrong thing in the street or not, that's the different thing. But if you do not have your food in your belly, your democracy or all the democracy or freedom, everything run away with the speed of light. And that I experienced when I was a young and child in the school. I know what is poverty. I know how hard it is life. Clear? So that's a simple thing I want to say. But we are in democracy. We need to say these things whether it's right or wrong. But we are not talking about the politics. All right, now here, young people, this problem, look at here, how many moving links we have? We have our OA, we have our ABCA, it's a one link, and we have our BD, and we have our piston. So we have our link 2 is a moving link, it is rotating in relation to O, and our ABCA, another link also moving, and our BD also moving, and our piston D also moving. So we have 4 moving links. Link 2, which is our OA, link 3 with the triangle, and BD is our link 4, and our link 5 is having the motion. And of course ground 1, so it is a 5-bar linkage mechanism. It is one moving links less than your assignment. Your assignment has a 5 moving links. Your OA, your ABCA, your BE, and your OE. No, OE is ground. Your the CD and the link and the piston D. Okay, so many of you think that this problem is easier than your assignment, but actually it is not. Actually, degree of difficulty, this problem is bigger than your assignment problem that you did graphically, velocity and acceleration and so on. So look at here. Our objective is to find the velocity at point D, acceleration at point D, and also velocity at point B and velocity at point C. And now for your information, our link OA has a rotational motion in relation to O, and our piston D has a translational motion in relation to, it can go left and right. But our ABCA, the link 3 undergoes general plane motion, and our connecting rod BD also undergoes a general plane motion. It means the velocity at point B and velocity at point C, and also absolute acceleration at point B and absolute acceleration at point C is neither perpendicular nor parallel to any of the links, any of the sides. Clear to everyone? In your assignment, velocity at point B, you know the direction. Why? Because your BE is rotating like that in relation to E. That's why you wrote your BB is perpendicular to BE. Is it clear? Because you know it is a rotational motion, your link BE, link 4. And your A, the velocity VA, also you know the direction, because your OA is rotating in relation to O. But you could not say the same thing for your point C in your assignment, because your point C is a general plane motion. It has, and you saw when you position, you saw it is neither circular path, is neither circular nor straight line. It is a very complex shape depending on your geometry. And all other section, the D is moving pure straight line, and your A is moving pure circular path, and your B is moving half circular path or quarter circular path. Is it clear? That's why the point where it does not depict the pure circular path or a straight line, that path is undergoing general plane motion. Simple way to understand. Okay. So here, our point B, also a problem. Our C, also a problem. And now young people, we have a little dilemma, but it is not absolutely a problem. One good thing is, in our assignment case, we were required to find the velocity BD. But here, luckily, the velocity BD is given to us. And that's the only savior. That's the only savior. And now have a look. Both point B, the velocity BB, direction we don't know. And velocity VC, we also don't know. And my question is, which point we should try first to find? At point C or at point B? B. Why? Because we can set up two equations for B. BB equals the BB equals known point A to unknown point B. And the second equation from known point D to unknown point B. Clear to everyone? Because at point D, our BD was given. Clear? That's why we'll be able to tackle like this approach. But if you think, no, Professor Firoz, I think the B is connected with the D and all the complicated thing, I can clearly see that D is not connected with the C. I'll be moving to point C first to find velocity and acceleration, and then I'll be trying to find our velocity and acceleration at point B. It will be committing suicide. It will be just committing suicide. You have nowhere to go. And that's why I told you, we engineer always, before we take a decision how to do something, we need to develop our own strategy first. That how we will be achieving that. So this is why we will be, to us, as this point is a no-go zone, will not go here at all. We will go to point B. Why? Because we can set up two equations exactly like our here. Instead of C, we write B. Clear everyone? And that one will be our BA, and that one will be our BBA. Clear? And then this one will be our BB, and that one will be our BD, and it will be that one, the B related to D. Clear? Which I have done next. So we explain our strategy, we do it. Okay, young people, look at here. We don't need to explain a lot because we already gone through significant part, and you know the process is exactly the same. I'm not making a new process. Same process, same approach we are doing just now things, because first 2, 3 I need to do a little bit of more you to bring same all in same pace. Now you can move with the speed. So look at here. I wrote using relative motion. Our BB equals what I said here. I actually wrote that equation here, and then I equalizing that. I eliminated our BB because you can write when you solve the problem. You can write that in our problem, point B and point C undergoes general parallel motion. That's why our strategy is we'll be going to find velocity and acceleration at point B, because at least we know the velocity on the other side of the link, VD, is known to us. That's why, that's what things, we want to see engineer to little bit right why you are doing it. It is not a solving or number crunching. Number crunching, nobody likes it. We always need to show our understanding, and then you will not forget. Otherwise, young people, you forget it soon. And our objective is not to forget it, because we will be applying this knowledge in real life. This dynamic subject knowledge, you don't even believe it. The knowledge of this subject will help you to specialize in noise and vibration. And noise and vibration, if you little bit of expert in this area, anywhere in the world, any mechanical engineer specializing in noise and vibration, they never be unemployed. Because every machinery, every object that moves, either linear or rotational, they always will experience some vibration. And to tackle that vibration, minimize that vibration, you need the knowledge from this subject. Clear to everyone? Therefore, if you know these things, your machinery's life you can extend. And your company boss will be liking you. Otherwise, they will be every now and then they need to replace the machinery, which is nobody wants it. Everyone wants to make money. This is the reason. So we develop this one. Of course, our BA we know perpendicular to our OA is going this way because omega is following that way. Young people, look at that. I already told that. And then our BBA, we also know its value, omega 2 times that length. And then BBA will be perpendicular to AB. We already wrote it. And then our BD, we already know it is parallel to horizontal direction because it is going in that direction. As you can see, it is right. And also we know its value. And our BBD will be perpendicular to the relative direction. So from there, we construct a vector polygon, and we find our BB from there, which is in the next slide. Which is our next slide. Okay, young people, have a look quickly. We need to go with the speed of light. We have only a few minutes left. Okay, so what I did, I wrote, don't worry about this equation. We are solving at the moment our point B. So we did this is our origin or starting point, and from the starting point we wrote that our BA is going that way parallel to not parallel, perpendicular to our OA. It is there. It finishes here, and from that point will be our BBA, which is the 90 degree angle of our AB, and that line is this line, beautiful line, is your BBA. Can you see that BBA? And also, I'm not sure how many of you noticed. How many of you noticed my vector polygon? Have you seen that every line I use the different color? Why I did? You wanted to, you think that I made a beautification? Yes? Someone said something here. Yes. Because all are the same color. Believe me, even with my expertise, with my knowledge, sometimes I confuse. What is my BBA? What is my BCA? What is my other line? Is it clear? Our engineering job is not to confuse other people. First of all, not confuse to myself or ourselves and also other people. That is our job. That's why. In extreme circumstances where you don't have that excess of this color, then of course you try your best to other color. Clear? Alright, now, hey, look at here. We did that line because where our BA finished at that point, and then our BBA will start from the T for BA, but it can go to that direction or that direction perpendicular to AB. So I draw a big dotted line all the way there, and that I wrote far away, BBA perpendicular to AB. Clear? We finish our left hand side, and the right hand side our BD. Which way our BD is going? In our diagram to the right, but it should start from where? From the origin. Why? Because for two reasons. One is the link of our D has a connection with ground, so therefore that velocity or its acceleration should start from the origin. And it is also one letter index, D, one letter, so it should start from the origin. Hey, young people, look at that, how many times I already said. You already become a little bit familiar. You don't need to memorize that point I wrote it. Do a couple of times, it will come automatically in your head. No memorization. So we did this one, and where our BD finished, our BBD perpendicular to BD will be starting from the tip of our BD. It can go upward, it can go downward. So what I did draw a big dotted line up to that point. Clear to everyone? And our BBA unknown and our BBD unknown, and we can clearly see if our BBD goes up and our BBA goes this way, unfortunately it is diverging. Our vector polygon will not close. So therefore we can clearly see if our BBD come down and our BBA come down, at that point they will be intersecting. Same approach we did so far. And therefore now is, we found our unknown thing. It means from here all the way up to that point where it meets our BBA, that length will be our BBD. Clear? I made continuous line. And then from here where our BA finished, BA finished, from here all the way up to that point, that will be our BBA. And now BA, BBA. If I put a diagonal, that will be my BB. As clear to everyone? And similarly, in our equation 2, BD, BBD equals BB. Can you see that? BA plus BBA equals BB, and BD plus BBD also equals BB, as per our equation 2. We answered. And now you can go to C. No problem at all. You don't need to worry about your life. You are absolutely safe to go to now C. we will be setting again two equations. Now we know velocity at point B. We also velocity at point A we already know beforehand. So we'll be setting exactly two equations. BC equals BA plus BC relative to A, and BC equals BB plus BC relative to B. Clear to everyone? From here, see, look at here. We already know now B, velocity, which is this one. This is our BB. Clear to everyone? And then our equation is there, so we again same equalizing it. We eliminated our BC temporarily, and then our BA we already have it here. Look at there. We don't need to plot BA again. Our BCA will be perpendicular to AC, which is going this way from the tip. It can go this way or it can go downward. At this moment, I have no clue whether it is going upward or downward. So I draw a big dotted line passing through the tip of BA. That is our BCA perpendicular to AC. I have written. And then on our right hand side, VB, and this is our beautiful VB, and the red color, you cannot forget it. And then where our BB finished, our BCB will start from the tip of BB. Nothing to do with our BBD, nothing to do with our BBA. I am looking only where is my BB finished. Our BB finished here. Clear? You see how I ignore other point? Because that is not our important thing. Important thing is which one my equation is connected. So now BCB, it will be perpendicular to BC, and that is the line I draw, because our BCB can go to that direction, can go that direction from the tip of BB, and BB is the entire red dot line. And then I can see this my beautiful under dotted line, and then my BCA dotted line intersect at that point. So therefore from here up to that point is our BCA, and from here up to that point is our BCB. And of course from diagonal, if I draw a line, sorry, not diagonal, from the origin here, and that will be our absolute BC with the speed of light we found. Is it clear from this side? Because I am you are a little bit behind of me. Is it clear? Is it a hard thing? Is it a hard thing? No. Only you need to remember a couple of processes. And those processes, if you, some of you, I saw you recorded, and you look at here back, and you can clearly see the same pattern I am talking. Yesterday I talked, today I also talked. Same thing. And also I said, in your, I have some recording of the graphical, and also some other areas, but graphical particularly, which I did for our onshore student in Melbourne during COVID time. So what I did, I will give you access those recordings. You can also download them or listen them when you have a time. Okay? Because to me, you and my Melbourne student all are same. I want your knowledge level will be the same knowledge level what I did in Melbourne. Clear?